Okay, the next thing we're going to talk about is the period of the sine and cosine function. Okay, so the definition of the period, okay, it's the length of one full cycle of the graph. Okay, so if we go back to our original sine and cosine function, okay, here's sine. The length, if you just have a regular y equals sine x, okay, the length of one cycle is 2 pi, right? So it starts at 0, it goes all the way up, all the way down, all the way, okay, back to 0, and it's going to start over. Okay, so one full cycle is 0 to 2 pi, because when it hits 2 pi, then it's going to go up again and repeat the cycle. Okay, so the period of a regular sine graph is 2 pi, sorry, and cosine is the same, right? One cycle is 2 pi. Okay, start to finish. And then once you get to 2 pi, it's going to repeat again. Okay, however, when we start adding numbers in, multiplying the function, okay, that changes the period. Okay, but let me go back here. Okay, so to find the period, if we have our graph written in standard form, which is a sine of bx plus c plus d, okay, the period of that is 2 pi divided by the absolute value of b. And it's the same for the cosine function. Okay, it's 2 pi divided by the absolute value of b. Okay. So back to example 2. Okay, example 2, find the period of each function and use the language of transformations to describe how the graphs are related. Okay, so let's start with the function y equals the cosine of x. Okay, so to figure out the period, we need to look at the number in front of x, right? Because that's b. We need to look at the number in front of x. So in this case, since we don't see a number here, it's 1. Okay, so the period is 2 pi over the absolute value of 1, or just 1. So our period is 2 pi, which we already said, right? The period of a regular cosine, that parent function, y equals cosine of x, is 2 pi. Okay, well, let's look at another one. Let's say that we have y equals -2 sine of x divided by 3. All right, so to figure out the period, I need to know the number in front of x, okay, which means that I need to rewrite this as y equals -2 sine of 1/3 x, right? 1/3 x is the same thing as x over 3. Okay, that means in this case that b, the number in front of x, is 1/3. Okay, so my period here is 2 pi divided by 1/3, which is 2 pi times the reciprocal of 1/3, which is 3, right? To divide fractions, I take the numerator and multiply the reciprocal of the denominator. Okay, so the period is 6 pi. Okay, so there's my period. Now I'm supposed to talk about transformations. Okay, so let's look at a few things here. Okay, so I have this right here, I have the negative sign, I have the 2, and then I've got the 1/3. Okay, so the negative sign is a reflection across the x-axis, right? When we multiply that function by a negative number, it reflects it across the x-axis. Okay, the 2, when I multiply a function by a number, that's either a vertical stretch or a vertical shrink, since 2 is greater than 1. Okay, it's a vertical stretch. And then I have the 1/3. Okay, so here's where it gets tricky. When I multiply by a number inside the function, okay, that's my horizontal stretch or my horizontal shrink. So just like when I add, right, it moves the number to the left inside the function. If I subtract inside the function, it moves the number to the right. Okay, if I multiply by a number, that's going to be a horizontal stretch or a horizontal shrink. Okay, horizontal, just like when you're adding and subtracting, it seems like if you add inside the function, it should move it right, but it doesn't. It moves it left. Okay, and when I subtract inside the function, it moves it right. Okay, the same thing when I multiply. When I multiply by a number inside the function, okay, since this number, it's like opposite of vertical stretches and shrinks. Okay, because this number is between 0 and 1, it's actually going to be a horizontal stretch. Okay, and not only is it going to be a horizontal stretch, it's not going to be a horizontal stretch by 1/3. I'm going to flip that fraction, I'm going to take the reciprocal, and it's a horizontal stretch by 3. Okay, so reflected across the x-axis, vertically stretched by 2, and horizontally stretched by 3. Okay, let's say that we have y equals 3 sine of negative 2x. Okay, so let's start with the period. This is really straightforward, right? It's negative 2 times x. Okay, that means b, okay, it is the number in front of x, okay, but it is the absolute value of that number. So my period is 2 pi over the absolute value of negative 2. So the 2 pi over 2, which is pi. Okay, so the period of this function is pi. Okay, let's talk transformations here. Okay, so a couple of things going on, right? The function's multiplied by 3. Okay, so that's going to be a vertical stretch. On the inside, it's multiplied by negative 2. Okay, so I'm going to separate these out. All right, so when I multiply the function by a number that's greater than 1, that's a vertical stretch. By 3. Okay, once again, when I get inside the function, it just gets funky. Okay, the negative's not too bad, but if I make what's inside the function negative, okay, that's a reflection across the y-axis. Okay, so if it's out in front, the whole function's negative, that's across the x-axis. If it's inside, it's a reflection across the y. Okay, this, because 2 is greater than 1, is going to be a horizontal shrink. Okay, a horizontal shrink. And, okay, I have to again, take the reciprocal. Okay, so it's a horizontal shrink by 1/2. So the language of transformations when you get to horizontal can sometimes be tricky. It's the opposite of vertical. Okay, vertical stretch and vertical shrink is pretty basic. Horizontal stretch and horizontal shrink, it's the opposite of that. And not only that, but you have to take the reciprocal of the number, so don't forget that.